When you look up at a commercial jet leaving a trail across the sky, it's really tempting to just see an impressive machine.
Right, just a piece of engineering.
Exactly. But you are really looking at a real-time flying economic indicator. And today, our mission is to unpack the Q2 2026 earnings report and the SEC 10Q filing for GE Aerospace.
Yeah, we are looking at a company that practically owns the sky at this point. I mean, with an installed base of roughly 50,000 commercial engines plus another, 30,000 military engines?
Yeah, 30,000.
It's wild. GE Aerospace is just a definitive global bellwether. Their quarterly financial numbers, they reveal the immediate, ground-level reality of global travel demand, the health of complex supply chains, and the current trajectory of military defense spending.
Totally. Because when a single entity has 80,000 engines operating globally, generating over 2.3 billion flight hours of telemetry data, they hold the pulse of the industrial economy.
They really do.
So whether you are analyzing this sector for capital allocation, or you simply want to understand the mechanics of global infrastructure, we have you covered. Okay, let's unpack this. Because to truly grasp the current state of aviation, we first have to examine the sheer scale of capital flowing into GE Aerospace right now.
Yeah, and the financials in this Q2 report are just structurally massive. I mean, total orders hit $16.5 billion.
Wow.
Right? Which represents a 17% increase year over year.
And adjusted revenue reached $12.6 billion, so that's up 24%. And then adjusted earnings per share came in at $2.22, up 22%. But the metric that stands out most sharply, at least to me in the 10Q filing, is the free cash flow.
Oh, absolutely.
They generated $3.0 billion. That is a 43% jump from this time last year. Like, a 43% leap in cash generation is highly unusual for a legacy manufacturer with this much physical overhead.
It's unheard of, really, and I think it points to a fundamental shift in how the business operates. We're years beyond the post-COVID travel rebound at this point.
Right, this isn't revenge travel anymore.
Exactly. This revenue growth is no longer driven by a sudden surge in pent-up consumer demand. It's driven by brutal, calculated operational efficiency at the factory level. I mean, management has fundamentally restructured how they build complex machinery.
Yeah, and reading through the management commentary, they repeatedly attribute this efficiency to a framework called Flight Deck, which, I'm not going to lie, on the surface, it sounds like standard corporate phrasing.
It sounds like a buzzword.
Right. So how does an internal operating model actually translate to a 43% increase in literal cash flow?
Well, Flight Deck is their proprietary lean operating model, and it functions as a very strict, unyielding philosophy on the factory floor. So it prioritizes 4 metrics, strictly in a cascading order: safety, quality, delivery, and cost.
Okay.
And if the safety standard isn't met, the line stops. Period. You do not proceed to quality, and if quality fails, you don't proceed to delivery. It basically removes all ambiguity for the engineers and the assembly workers.
Wait, so is this essentially the Marie Kondo method applied to heavy manufacturing?
Wow, actually, that's a pretty great way to look at it.
Like, if a specific process or physical movement on the assembly line doesn't add direct value, or, in this case, meet rigorous safety standards, you just eliminate it entirely.
That analogy holds up surprisingly well, especially when you look at the physical implementation. The SEC filing actually highlights a very tangible example of this at their Lynn manufacturing facility.
Oh yeah, the F-110 engine part.
Right. Workers there assemble a critical component for the F-110 engine, which is a major military power plant. And by applying the FlyHD DIC model, management reduced the, quote, operator distance traveled by 55%.
Just to be clear, they optimized the literal distance the factory workers were walking during a shift.
Yeah, they remapped the entire floor. Because in heavy manufacturing, if a worker has to walk across a facility to fetch a specialized tool or transfer a sub-assembly, that transit time represents idle capital.
Because the engine part is just sitting there.
Exactly. It just sits there as work-in-progress inventory. So by restructuring the supply chain nodes within the factory itself to eliminate that 55% of wasted movement, the engine moves through the line faster. Less idle time means fewer bottlenecks.
That's incredible.
And that single operational philosophy, when you apply it systematically across all their global plants, it directly contributed to a 31% increase in total engine deliveries in just the first half of the year.
So the micro-logistics dictate the macro financial returns.
You got it.
I mean, for you, the listener, the next time you see a massive high-bypass turbofan engine hanging off the wing of a plane, consider that its timely delivery to Boeing or Airbus literally came down to engineers optimizing the footsteps of the assembly crew.
It's fascinating. And that efficiency in manufacturing, it brings us to the core of their business model,
Mhm.
because we really need to look at the specific segment generating the vast majority of this revenue.
Right, the Commercial Engines and Services segment, or
Yeah.
CES. Revenue here hit $9.7 billion for the quarter, which is a 27% increase. And when you break that down, equipment revenue,
Yeah.
the sale of the physical engines themselves grew 30%, heavily driven by ILAPE engine unit deliveries, climbing 24%.
Mhm.
But the services revenue also grew 26%, and that's driven by internal shop visits and spare parts.
And understanding the relationship between those two numbers and the equipment and the services is crucial for understanding aerospace economics. I mean, it relies heavily on the classic razor and blades model.
Right.
GE sells the complex equipment, the jet engine, often at a lower margin.
Mm.
In the case of brand new, state-of-the-art architectures, they might even take a loss on early deliveries.
So the engine is the razor handle.
Exactly. The long-term cash flow comes from maintaining, servicing, and overhauling those engines over a 20 to 30-year lifespan. The spare parts and the shop visits, those are the blades.
Well, okay, I want to push back on the margins here for a second.
Yeah.
Because the numbers in the filing present a really fascinating contradiction.
Okay, let's hear it.
If total CES revenue is up 27% and operating profit is up 20%, why did the profit margin for this specific segment actually drop by 160 basis points down to 27.3%? I mean, if their highly profitable services division is growing at 26%, shouldn't the blended margin be expanding, not compressing?
That is a great catch. That margin compression is a direct result of something called the cost of growth, and it relates exactly to that razor and blades dynamic.
Okay, how so?
Well, GE is currently in the middle of a massive delivery cycle for new equipment. They are pushing out brand new, incredibly complex engines like the GE9X for wide-body aircraft and the LEP engine for narrow bodies.
So the equipment sales are basically outpacing the historical baseline.
Yeah, they grew by 30%. And manufacturing these new engines involves massive initial costs, heavy research and development amortization, and the lingering effects of global inflation on raw aerospace materials.
Oh, I see.
So because that lower margin equipment business grew faster than the higher margin services business, the overall average margin for the segment temporarily dropped.
So they're actively subsidizing the expansion of their future installed base,
Precisely.
taking a slight hit on the blended margin today to get those engines bolted onto wings, which mathematically guarantees highly profitable service contracts for the next 3 decades.
It is a totally calculated investment in future cash flows. And this specific engine driving that initial margin squeeze, the LEP engine, is dictating the current economics of the airline industry.
Yeah, the demand is undeniable. The report notes that Copa Airlines just finalized an order for up to 120 LEP-1B engines to power their growing fleet of Boeing 737 MAX aircraft.
That's a huge deal.
It is. But the more critical engineering update in this 10Q, I think, is that GE officially completed certification for a new LEP-1B durability kit.
Right, the new kit.
Yeah, which centers around an upgraded high-pressure turbine blade, or HPT blade.
Mm-hmm.
But why is the redesign of one specific blade moving the needle for a multi-billion-dollar segment?
Well, the high-pressure turbine sits immediately downstream of the combustor, so it faces the most violent environment in the entire engine. It operates in temperatures that actually exceed the melting point of the specialized alloys it's made from.
Wait, really? It operates above its own melting point?
Yeah. It survives through complex internal cooling channels. But because of that extreme thermal and physical stress, the HPT blade degrades faster than any other component. It dictates the time on wing metric for the entire engine.
Time on wing being the absolute holy grail for airline operators.
Exactly.
It's the ultimate bottleneck. I mean, it functions almost like a smartphone battery, right?
Yeah.
No matter how advanced the rest of the hardware is, the device is completely useless the moment the battery degrades.
That's a perfect way to think about it. And by upgrading the metallurgical properties and the cooling architecture of the specific blade, this durability kit is projected to deliver a 2x improvement in time on wing.
A 2x improvement.
Yeah. The engine can operate for twice as many flight cycles before it requires a costly, intensive teardown.
Wow. For a carrier like Copa Airlines, managing a massive narrow-body fleet, doubling the time an engine spends generating revenue rather than, sitting in a maintenance hangar, that fundamentally alters their operating leverage.
No, absolutely. Furthermore, GE basically compounded that engineering upgrade with the operational improvements from flight deck that we talked about earlier.
Right.
The filing notes they successfully reduced LEAP turnaround times in their repair shops by more than 2 weeks year over year.
2 weeks is an eternity in commercial aviation.
It really is. So the combination of parts lasting longer and repairs happening faster led to a statistic management was very eager to highlight. They have achieved, quote, nearly zero engine-driven grounded aircraft for their customers.
That is the ultimate value proposition for an airline. I mean, GE dominates the commercial sector by keeping planes in the air, but the filing also details some pretty significant movement in military and future technologies.
Yeah, let's talk about that.
The Defense and Propulsion Technologies segment, DPT, recorded $3.4 billion in revenue this quarter.
And those military contract wins provide a critical baseline of steady revenue. Like, they secured orders for F-404 engines for Turkish Aerospace to power the new Hürjet program and CT-7 engines for the UK Ministry of Defence's new helicopter fleet.
Yeah.
These are proven, mature platforms that offer really reliable margins.
Sure, but the real story in the defense segment lies in the future applications. Because GE's total company backlog currently sits at over $210 billion.
It's a staggering number.
It really is. And buried within that backlog are contracts that read like next-generation aeronautics theory. For example, they secured a U.S. Air Force contract to complete the preliminary design review for the GE 426 engine, which is intended for an autonomous collaborative platform.
Right, which is the technical designation for AI-driven drone wingmen designed to fly alongside human-piloted fighter jets.
It's just wild to think about.
It is, and the engineering paradigm for an autonomous collaborative platform is entirely different from traditional defense manufacturing.
How so?
Well, a manned fighter jet requires an ultra-reliable, highly expensive engine because, obviously, human life is on the line. But a drone wingman requires an attritable engine.
Attritable? Like disposable?
Essentially, yeah. It needs sufficient thrust and reliability, but it must be manufactured at a fraction of the cost because the military expects to lose some of these drones in combat.
Right.
So developing an engine that balances high performance with low-cost, expendable manufacturing requires a massive pivot in design philosophy.
And in addition to attritable drone engines, the filing notes they successfully completed the first ground test for a NASA project focused on a megawatt-class hybrid electric engine.
Yeah.
I mean, a megawatt of power is enough to run a small neighborhood, and they were packaging that into an airborne powertrain.
It's incredible engineering.
But how does a legacy industrial company balance the immediate demand of churning out commercial loop engines while simultaneously funding foundational research into hybrid electric flight?
The financial mechanism enabling that R&D is the $210 billion backlog itself. That figure basically functions as a massive structural safety net.
Okay, explain that.
When management has over $200 billion in legally contracted future revenue sitting on the balance sheet, it shifts their time horizon. They aren't forced to cannibalize future innovation to meet short-term quarterly targets. They can afford to invest heavily in the NASA Electrified Powertrain Flight Demonstration Project because the cash flow from the commercial service side is mathematically guaranteed for decades.
So they use the reliable profits from the razor and blades model today to ensure they own the underlying technology when the industry inevitably transitions away from traditional fossil fuels.
Exactly. Aerospace operates on 30-year product cycles. So whether the market eventually dictates sustainable aviation fuel, hydrogen combustion, or hybrid electric architectures, GE is using its current balance sheet to fund tomorrow's dominance.
And that combination of a $210 billion backlog and the aggressive operational leverage from the Flightjet DIC rollout, it clearly gave management the visibility to make a bold claim about the remainder of the year.
They really stepped up.
Yeah, CEO H. Lawrence Culp Jr. announced they are raising their full-year 2026 guidance across the board.
And the revisions are pretty significant. I mean, they originally modeled adjusted revenue to grow in the low double digits. They've now revised that upward to high teens growth.
Nice.
And operating profit expectations were bumped up to a range of $10.55 to $10.75 billion.
But again, we have to return to the cash flow. They raised free cash flow guidance to between $8.9 and $9.2 billion, highlighting a greater than 100% conversion rate.
Yeah, that's the key.
For a listener looking at heavy industrial companies, the implications of a greater than 100% free cash flow conversion are profound.
It really is a rare metric in capital-intensive industries. Free cash flow conversion measures a company's ability to turn the accounting profit logged on the income statement into actual liquid cash in the bank.
Which isn't always a guarantee.
Not at all. In heavy manufacturing, profit is frequently trapped. It gets tied up in massive physical inventory or in capital expenditures required to build new factory lines or even in receivables from airlines that just haven't paid their invoices yet.
Right, so a company can show record profits on paper, but actually struggle to make payroll if that profit isn't converted to cash.
Exactly the risk. So when GE reports a conversion rate exceeding 100%, it means their cash collection is actively outpacing their net income.
Oh, wow.
Yeah, they are extracting cash from previous investments faster than they are required to reinvest capital to maintain growth. They're aggressively managing inventory and collecting receivables.
And this liquid efficiency is precisely what allowed them to execute a $2.0 billion share repurchase program in the second quarter alone, right?
Yep, they have the discretionary cash on hand to directly reward shareholders without taking on debt.
Well, I have to play devil's advocate regarding this revised guidance for a second,
Fair enough.
because the financial models look pristine, but the SEC 10Q filing, the actual legal disclosure, is layered with cautionary statements. They outline severe macroeconomic risks, cybersecurity vulnerabilities, and most notably, ongoing supply chain fragility.
The supply chain is always the elephant in the room.
Right. And the filing mentions that material input from priority suppliers improved by double digits, but building a jet engine remains one of the most complex logistical puzzles on Earth.
It does. The supply chain remains the primary constraint on growth. An aerospace manufacturer relies on a globally distributed network for highly specialized titanium forgings, intricate electronics, and rare earth metals,
There's so many moving parts.
literally and figuratively. A labor dispute at a single sub-tier supplier or a geopolitical disruption affecting one shipping lane means a multi-million-dollar engine just sits unfinished on the factory floor in Ohio.
It's the ultimate bottleneck. I mean, management is raising guidance because the flight deck system is currently optimizing everything within their direct control, but the 10Q makes it abundantly clear they are highly exposed to global stability.
Very true. They are operating with immense efficiency, but they're still walking a logistical high wire.
Well, to synthesize this deep dive for you, the listener GE Aerospace has successfully transitioned into a hyper-efficient, highly profitable, pure-play engine manufacturer. Through rigorous operational frameworks like flight deck, they have structurally reduced manufacturing friction.
They've dialed it in.
And through material engineering breakthroughs like the LE Durability Kit, they're basically doubling the time their engines spend generating revenue for airlines. Plus, they are funding the development of autonomous military platforms and hybrid electric powertrains, all supported by an unprecedented $210 billion backlog.
Honestly, understanding these dynamics fundamentally changes how you perceive the mechanics of global aviation and industrial finance.
It really does. The next time you are waiting at a boarding gate, take a moment to look out the window at the engine on your aircraft. Consider the sheer scale of thermal engineering, the global supply chain orchestration, and the massive capital allocation required just to get that single piece of machinery onto the wing.
It's a modern marvel.
But I want to leave you with a final provocative thought to consider, building on the long-term R&D we just discussed. GE generates the vast majority of its profit from its services division, repairing and replacing the complex, high-heat, moving parts of traditional jet engines over a 30-year lifespan.
The blades.
The blades, exactly. However, we know they are currently running successful ground tests for NASA hybrid electric engines. Electric motors, by their physical nature, have significantly fewer moving parts.
Right.
They do not rely on violent internal combustion,
Yeah.
they operate at lower temperatures, and historically, they experience vastly lower physical wear and tear.
Where are you going with this?
Well, if GE Aerospace successfully solves the engineering puzzle of hybrid electric or fully electric commercial flight, electric powertrains will require a fraction of the maintenance of today's turbofans. So, will the pursuit of clean aviation accidentally engineer away their incredibly lucrative repair business model?
Oh, man. That's a fascinating problem.
It is a structural paradox at the heart of their future, and it is definitely something for you to keep a close eye on over the next decade. Thanks for joining us on this deep dive.